Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome to a new video, content video. This is Salhi Faiza, assistant lecturer at Al Jiswan University at the disposal of Khenchela University. For more information, you can contact me at my email address. This presentation is about Thermodynamics 1 course content and also a presentation of the first course from the first chapter. The presented lecture provides the necessary foundation of classical thermodynamics for applications of combustion and thermal machines, also provide an in-depth understanding of the laws of thermodynamics, thermal cycles, and the properties of substance in transformations. Thermodynamics 1 composed of 6 chapters as it is illustrated here in this mind map, hourly volume, and the relationship between chapters and lectures. Now we will move to the content of the first chapter. The first chapter in Thermodynamics 1 is about fundamental properties of state functions, include definitions of thermodynamic systems and the external environment, description of thermodynamic system, evolution and thermodynamic equilibrium state of system, possible transfer between system and the external environment, transformations of the state of system means operation and evolution, and finally a reminder of the ideal gas law. Now let's move to the chapter number 2. The first principle of thermodynamics. The first principle of thermodynamics states that energy cannot be created or destroyed. However, it can be transformed from one form to another. This chapter focuses on the concept of energy, the application of the first law of thermodynamics to the ideal gas, the enthalpy function, heat capacity, and reversible transformations. The third chapter, the thermodynamics first law application to thermochemistry. This chapter includes heat of reaction, the standard state, the enthalpy, Hess and Kirchhoff laws. Generally, this chapter is about the enthalpy, where the enthalpy is denoted by H, refers to the measure of total heat content in a thermodynamic system under constant pressure. After that, the fourth chapter, the second law of thermodynamics. The second law of thermodynamics states that heat energy cannot transfer from a body at a lower temperature to a body at higher temperature without the addition of energy. This chapter is on the calculation of the entropy in the various reversible transformations: isothermal, isochoric or isovolumetric, isobaric, and adiabatic transformation. The fifth chapter, the third principle and absolute entropy. The third law of thermodynamics states that when the temperature approaches to the absolute zero, the entropy of a system approaches a constant value. At absolute zero temperature, the entropy of a pure crystalline solid is zero. This chapter includes the calculation of the absolute molar entropy of pure body, the entropy of a chemical reaction, and finally the variation of the entropy as function of temperature. And finally, the sixth chapter, free energy and enthalpy criteria for the evolution of systems. This chapter includes an introduction, energy and free enthalpy, and finally chemical balances in the frame of continuous control, and in the end of each chapter, an individual test will be effected in order to evaluate students' knowledge. And now, let's move to our lesson, Thermodynamics System. The term thermodynamics is made of two terms, thermo and dynamics. Thermo means heat, and dynamics, a mechanical motion that requires work. The field of physics states that the relationship between heat and other types of energy is called thermodynamics. There are various concepts in thermodynamics. Some of those concepts are explained as follows. Thermodynamic system. A thermodynamic system is that part of the universe which is under thermodynamic study. So, a system is a region containing energy or matter that is separated from its surrounding by boundaries or walls. Surrounding is everything interact with the system. A boundary is a closed surface surrounding a system through which energy and mass may enter or leave the system. We can distinguish different types of boundaries: real or imaginary, rigid or non-rigid, permeable or non-permeable, and finally adiabatic or non-adiabatic. The system and surrounding combines up the universe. Depending on the type of the boundary, thermodynamic system can be described in three classes. The first one, an open system. A system said to be open system if it can exchange both energy and matter with surrounding. Number two, closed system. Closed system can exchange only energy but not matter with its surrounding. And finally, the isolated system. The isolated system cannot exchange energy and matter with its surrounding. Thermodynamics properties. In general, thermodynamics properties can be divided into general classes: intensive and extensive. An extensive property is a property of matter that depends only on the type of the matter in the system and not on the size or the amount. Example, color, melting and boiling point, temperature, pressure, concentration, etc. An extensive property is a property of matter that depends on the amount of matter in a system. Example, Gibbs energy, enthalpy, entropy, volume, etc. Let's take an example. Imagine you have 1 liter of water at 300 kelvins and you add another liter in the same temperature. Then you will have 2 liters of water in 300 kelvins. In this case, we have two parameters, temperature and volume. As it is noticed that we didn't add the temperature, however, we add the volume to get 2 liters. So, temperature in this case is an intensive quantity, where the volume is an expansive quantity. And now we will pass to another point, state of a system. A thermodynamic state of a system is its condition at specific time. When the properties of a system define the state of that system is called state variable. Considering a gas in a beaker with movable piston. This is presented by state 1. State 1 is presented by the following variables P1, V1, and T1. Those variables are at fixed value. The gas can be cooled or even heated at constant pressure, constant volume, or even constant temperature. Then the system will switch to state number 2 with new variables P2, V2, and T2. Therefore, the state may be represented by certain observable properties that we called state variable, such as pressure, volume, or temperature. That was all for today. I hope you enjoyed it. I'm always here to share knowledge and provide support. Please feel free to contact me at any time. See you next time. السلامة.